Welcome back to Daily LeetCode 104. We are back once again. I think yesterday we ran out of time, so we didn't get to finish. But someone mentioned what are the other things that I learned, and I think that was the question I was answering yesterday. So I try to do to break it up into mods, because I think on the Huberman Lab podcast, the buffest scientist on the internet, he mentions that the learning sessions should not exceed, or ideal learning session would be about an hour and 30 minutes. That's what I try to do, but breaking it up, now I remember what I was mentioning. Yeah, breaking it up kind of messes things up. So the best way to kind of have a bunch of habits work is to chain them. So I chained them, but then I reached my max block quicker. So that became an issue. So yeah, so now I'm trying to find a system that works, but I would say right now we do like 3, including LeetCode, it's about 3 to 4 hours daily. A lot of time. So it remains to be seen. I think today was one of those days I didn't start the day with LeetCode, so I think it just didn't work out well. The video is going to be uploaded later today, but I think routine, so there's something to routine. So usually we do LeetCode in the morning, and I think it just starts the day off right, because you already have something that you kind of wanted to do under your belt. But I think I didn't get to do that today, so today I was just off the whole day. So that is unfortunate. So doing LeetCode in the morning, I think it's just the best way to do it. So that way you already have a win under your belt, you're already feeling good, and then by the time the end of the day comes around, you have more juice for maybe a personal project, something else, or maybe just another interest. So that's kind of tough. If I mentioned though, what is your LeetCode handle? FBI confidential information. I'll have to talk to the shareholders to see if I can release it. I'll get back. So I'm going to have to consult the HCC stakeholders. So once I consult the HCC stakeholder, that's going to be T. Wong, the bearer. I'm just that guy. Once I consult the stakeholders, we'll see if we can release it, but it remains to be seen. I hate ugly number questions. True. Too. Same. Dude, anytime a question, I feel like whenever a question devolves to whenever a question devolves to just you having to be able to write a proof, like the ancient Greek philosophers, it feels bad, man. Like there's one problem I think it was about like how to count a specific set of numbers in like a matrix or something like that. And then the only known way to solve the problem is actually a specific Greek dude who figured this out, and his name was Aristosthenes, and the solution is literally called like the Aristosthenes shuffle or something like that. And so if you're asking this question as an interview question or just in general, the only way that you get this right is if you've seen this problem before or you are Aristosthenes. So it's just very nutty. But yeah, that's what the ugly number question feels like. Granted, that question right here has more to do with, I guess, understanding prime factorization. But yeah, I think that gets away from the puzzle aspect. It's just a little too mathy. But me too, Thomas. Me too. So I forgot that we said we would do the weekly contest. So we're going to do the weekly contest. I'm curious to see how Thomas did on this. We're going to see. It looks like this one's harder than the last 2 weeks, because I think 2 weeks ago the best finish time was 5 minutes. Last week it was 6 minutes. This one is 8 minutes. So, and it looks like the runners up are 10, 13, and 14, which I've never seen before. So it looks like this one might be pretty hard. So we'll see how far we can get, and then jump into it. And this is one of the ones where our LeetCode screen is going to be jumbled up. So I'm going to make my camera small, and then we're just going to have to figure out how to make this make sense. But yeah, trying to figure out a way to make the learning system a little more sustainable. Not sure how. It's definitely a work in progress. I think we're on like V3 of the system. I think what's definitely going to stay is LeetCode in the morning. It's just too good to replace. So that's definitely going to stay. And then I got to figure out when to do the other sessions. It's either bulked in with LeetCode before work or after work. But I'd really like to do the whole session in the morning. That way after work I could do like personal projects and stuff like that. So we shall see. Let me know in the comments if you do how you set up your learning sessions. And also shout out to everyone who joined the Discord recently. Lots of new souls. So awesome to see. Hopefully we can slay more algorithmic complexities as a gang. So we're forming an army, and the minimum, you got to be able to invert a binary tree with one hand tied behind your back, and you're gonna have to type the solution with your feet. So that's the bar to join the HCC. So you're gonna want to join because the bar is only getting higher. So we're gonna do the weekly contest today. See how far we get. We have an hour, and yeah, I'm just going to jump into it. Make sure to join the HCC. Very high bar. So yeah, you're gonna want to join before it's impossible to get in. So there we go. We have the timer, and so let's jump into the weekly contest. Bro, I want the LeetCode. I don't even want the LeetCode items. I want the LeetCode swag so bad. So if we ever win a contest, I just want a shirt. I just want a shirt. So we're going to start with sort the people in longest subarray with maximum bitwise and. So this is an easy, apparently. Sort the people. You are given an array of strings, names, and an array heights that consists of distinct positive integers. Both arrays are of length n. Parallel arrays for each index I. Names sub I and height sub I denote the name and height of the ith person. So there are n people. Return names sorted in descending order by the people's heights. So we have Mary, John, and Emma. We have their heights. We want to sort them in terms of tallest to shortest, right? But by their names. By Allison, second Bob. N is equal to names.length, and n is also equal to heights.length. We also have at least one person. All the values of heights are distinct. I think there is a linear time. Oh, no. There's no. I think the minimum complexity has to be n log n because you're sorting. But since they're all distinct, I'm sure there is actually a linear time version. But I think the solution we're going to go with, we're just going to create a map of their heights to their names, since their heights are distinct. So heights to names, and then we'll sort the heights array and then translate that array into their names. So we'll just stub that out here. We'll say translate heights, or we'll just say map heights to name, sort heights, transform heights are into names are, and then return. So let's try that. So we're going to map heights to name, which means we're going to need a hash where the default value for the hash is going to be an empty string, right? Since we want to map heights to name, we want to do 0, right? Going up to heights or names.length. Since they're parallel arrays, it kind of doesn't matter. Let me see if this is visible on the screen. I'll put it like this, and then we'll just call it IDX since it's since it's parallel. We can use the IDX in either array, and so we just want to say if hash dot key heights sub idx. So if we already have a key for this index, so if we already have a value or a name set for this height, we don't want to do anything. So it's really just when we don't have a key for a height, right? Then we'd like to say hash sub height sub idx equals names sub idx. Say end, and then I'll put hash, and then I'll just return an empty array to start. I just want to see what the output looks like. So 180 maps to Mary, 165 maps to John, 170 maps to Emma. So that works. And then we just want to sort the heights. Do that, we can just do heights, sort in place. We'll say H1, H2. We want to sort it in descending order. So we'll say H2 minus H1. And then I'll just put heights to make sure that that makes sense. Okay, so we have it output. Now it is sorted. And then here we're just going to say sorted is going to be equal to heights dot collect height, and we're just going to transform it. We're just going to get the name for that height. And then I think we can just return sorted. So our answer was Mary, John, and Emma. And what's their oh, let's just add the test case. And it should show us. Well, our answer was Mary, Emma, and John. Theirs was Mary, Emma, and John. And then we can try the other test case just to be certain. I think the solution here is Bob. Oh, wait a second. We didn't we should have looked at this example a little closer. Heights are distinct, but names are not distinct. So our current status, we map height to a name. Well, yeah, that I actually might still be fine. The names are the same. I think this might have gotten us if we were mapping names to heights. But let's see, actually. We get Bob, Alice, Bob, which is what we were supposed to get. So let's try submitting it. It says it says accepted, but let's see. Well, so it passes the test case. And it actually is not the worst Ruby solution. So, you know what? We'll take it. It's not the worst Ruby solution. What's the time complexity of this? N is going to be the same. Names and heights are the same. So, do a linear operation to create the hash. The hash at most will have n keys. And then we sort. So, that's going to dominate the linear time operation. So, best case sort is n log n. And I think if we remove puts heights, we probably have it pretty good. We were actually doing two sorts. Wait. Oh, no. We're not doing two sorts. We're doing one sort. So we dominate n log n with linear space. Linear space used by the hash, assuming each height is distinct, which it is. So you know what? That is good enough. So now we'll try longest subway with maximum bitwise and. This one sounds hard. So you're given an integer array nums of size n. You're given an integer array nums of size n. Given an integer array nums size n. Consider a non-empty subarray from nums has the maximum possible bitwise AND. In other words, let k be the maximum value of the bitwise AND. Let k be the maximum value of the bitwise AND of any subarray of nums. Then only subarrays with a bitwise AND to k should be considered. Turn the length of the longest such subarray. Bitwise AND of an array is the bitwise AND of all the numbers in it. Huh? A subarray is a contiguous sequence of elements within an array. So, okay, we're given integer array nums of size n. Consider a non-empty subarray from nums that has the maximum possible bitwise AND. In other words, let k be the maximum value of bitwise AND of any subarray of nums. Maximum possible bitwise AND of a subarray is 3. The subarray with that value is 33, so we return 2. One, 2, 3, 3, 2, 2. Bitwise AND of a subarray is 4. Longest. This gives me sliding window vibes. It's like the second weekly contest where the second problem is a sliding window problem. I think we can do this. I'm more comfortable with sliding window in TypeScript. Maybe we'll do it in the Ruby. It seems like we just need to get the longest. The problem is making it really convoluted, but I think what we need is the longest subarray. Let me move this down. Oh, we can see it actually. Longest subarray. Respect. We're just going to use with respect because that sounds cool. With respect to bitwise AND. So maybe we'll try a greedy approach, right? Iterate through array, and right, and then we can keep length of window, right? And on each iteration, we're gonna check, right? What's better or what's larger? What's larger? Bitwise AND of new number or new number itself. Well, basically we're saying if new number itself is greater than bitwise of new number, reset window to new number. If we reset window to new number, then this probably has to be in an else. And then outside of that, add number to window. Window so far. Then down here we can just return max. So we could keep length, which would be equal to float infinity, and we'll just set equal to negative infinity since we want the maximum window. And I wonder what are the small, oh, so the numbers, the length can be 1. I think we can safely put it at 1 when I iterate through the array. We don't need access to the indices, I think. So we can just do nums.each do num. Actually, we just started at 1, so that, actually, what could we start it at? If we had the first, for example, if the first number was 2 and we did bitwise with 1, we would get, what would you get from that? Bitwise, and you'd get 1. So I'm thinking to start, oh, what the heck just happened? I'm thinking to start, it might just be easier to have the first number equal to the first number, and then what we can actually do is just skip and we'll say that the number is going to be equal to num sub idx. How about that? Num is equal to num sub idx, and the length would be 1. I want to say what's largest. New number itself, we'll say if num is greater than bitwise and num, so the length equal to 1, bitwise equal to num, otherwise we'll do bitwise is equal to bitwise and num, and then we'll do length plus equal 1, and then we could do end, and then we'll say length. It might be easier if we call this cur length. We'll say max length is equal to curlen and max, the max of curlen or maxlen, and except maxlen is going to have to be set to negative float infinity. Let's see if this even makes sense. So given 1, 2, 3, and 4, let's just try that. Our output should be 1. So our curlen is going to be 1. Max length is going to be negative infinity. Bitwise is going to be set to 1. We're going to start at 2. So num's going to be equal to 2. Is 2 greater than 1 and 2? Yes. So cur length would be equal to 1. Right, and bitwise would now be equal to 2. Now max would still be 1. Now we're going to go to 3. Is 3 greater than 2 and 3? Yes. Cur length would equal to 1. Bitwise equal to 3. So I think it works for that case. Let's try nums. So we have 1, 2, 2. I'm just going to copy it so we have access to it. So you have 1, cur length equal to 1, max length equal to negative infinity, bitwise will be equal to 1. We're going to start at 2 here. Is 2 greater than 1 and 2? Yes, it would. So cur length is going to be 1, bitwise is going to be equal to 2, max length is still going to be 1. Now we're going to go to 3. Is 3 greater than 2 and 3? Yes. So curl length is going to be equal to 1. Bitwise it's going to be equal to 3. Curl length is going to be equal to 1 still. Now we're going to still be at 3. Now is 3 greater than bitwise and num? No, we'd still like to include it. So if we said equals, oh no. 3 is not greater than bitwise 3 and num. So we'd say bitwise would be equal to bitwise 3 and 3, which would give you 3, and curl length plus equal 1, which gives us a curl length of 2. And then we'd go to 2. Well, is 3 greater than 3 and 2? Wait, this might be more complicated than I thought. I don't think this works, but we'll see. Yeah, the answer is 4. The actual answer is 2, I believe. I think the issue I'm running into is that 3 in binary actually looks like 0B011. And 2 in binary looks like so 3 and 2 actually gives you 2. But once you 3 and 2 would give you 2. Maybe it's the beginning that's messing us up. What about 1 and 2? If you did 1 and 2, 1 and 2 would give you 0, I believe. Or what does and do? And just masks out the bits, I think. Let me double check. I have Note on my laptop. If I do 2 and 1, you get 0. 3 and 2. 3 and 2 gives you 2. So 1 and 2. 1 and 2 gets you 0. And 2 and 3 gets you 2. So if we start at 1, or starting at 1 with, we're starting at 2, 1 and 2, is 1 greater than 1 and 2? 1 and 2 should give you, 1 and 2 gives you 0. So is 1 greater than 1 and 2? Yes. Curl length equals 1. Actually, the num would be 2. Is 2 greater than bit 2 and 1? Yes. So curl length is 1, bitwise is equal to 2. Now we're at 3. Is 3 greater than 3 and 2. Yes, because you'd get 2. So curl length equals 1, bitwise equals 3. Now is 3 greater than 3 and 3? No, so we do bitwise equals bitwise 3 and 3, which gives you 3, and curl length would be now 2, or max would now be 2. Now we would say, is 2 greater than think this should fix it. Is greater than I think this is the actual solution. It's not. Oh wait, did I assume that the longest such subarray? So we have an array of 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. 1, 2, 3. 1, 2, 4, 5, 6, 7, 8, 9, 10. So you have 10 elements. Looks like the ideal answer is 8. I output 9. Let's see why that is. If num is greater than bitwise, the same answer would be like this. Use a custom test case 1, 1. We should get the wrong answer here of 5. Well, our answer is 4. New number itself is greater than the bitwise of new number. Let me see exactly why we failed. If we do 3, 1, 1, 1, 5, 5, and 20, 11, 91, get 4, 4, 51, which is definitely less. So you should have got all these together, curling. So the current length would be equal to 1. Then we'd start at 1, check if num and num is greater than or equal to bitwise, which it is. Our length plus equals 1. So all we get here, have a length of 8. I say, is the number greater than the bitwise? $311,000 is greater than 200,000. So we don't really. Now we check if num bitwise is greater than or equal to bitwise, which it isn't. This is a strange one. I don't understand. Unless all these numbers aren't exactly the same, but they are the same. I'm just going to create an R array to see exactly what we are returning. So we get 1, 2, 3, 4, 5, 6, 7, 8. Wait, our array is actually of length 8, so why are we returning 9? is greater than bitwise. I'm so confused. I don't understand. Why are we getting 3 instead of 2? Let me actually read through it. Curl length is equal to 1. Max length is equal to negative infinity. This might as well be equal to 1. Bitwise, num is equal to num sub 0. R, which is unnecessary. We don't need this anymore. Start with 1, then we go to 2. Or we start with 2. So okay, num equals num sub idx. We have 2. Is 2 greater than 1? Yes. And 2 and 1, which gives you 0 greater than bitwise? No. So we said curl length equal to 1, bitwise now equal to 2. And the answer we're returning here is 3 somehow. Then we go to 3, we say is 3 greater than bitwise? Yes. And num and bitwise is greater than. 2 and 3. I'm getting confused. If num is greater than or equal to bitwise, 3 is greater than or equal to 2, which it is, and 3 and 2, which is 2 greater than 3, it's not, so we'd restart. Okay, so now we're starting with 3. Now we're at the next 3. 3 is greater than or equal to 3, and num n bitwise is not greater than 3. So I don't understand. What am I trying to accomplish? We want the longest subarray with the highest bitwise and. Longest subarray with the highest bitwise and. Longest subarray with the highest bitwise and. If num is greater than or equal to bit. This is not the way. It's just easier to know. What if we just say, we don't want to do num is greater than bitwise because we want to do the bitwise and, but when you bitwise and, you basically always decrease in value, so it's pretty much just checking if the values are the same. What's the longest running subarray with the where the values are exactly the same? Pretty much the longest running subarray, the largest running subarray where the values are the same. In that case, we'll want to restart when num is greater than bitwise. So current length would equal 1. And the new number, we won't even just call it. If num is greater than max num, then max num now equals num, and curl length would equal 1. Else if max num equals num, then we're still in business. We'd like to keep adding numbers. There's no point in updating max num. We'll just do curl length. I think this might be closer to what we're oh, output is still 9. So in this one we get 3115, right? We start with curl length 1, max length 1, right? Is the same number, right, greater than the same number? No. So we do curl length plus equal 1, max length is equal to curl length, max length dot max. Then we go to here. It's greater than, no. 3, 4, 5, 6, 7, 8. And then we say, okay, is 200,000 greater than 300,000? No. So we say curl length equals 1, max num now equals num. We have 2, 3, 4, 5, 6, 7, 8. So we shouldn't get 8 again. So when we want to restart is if max num is greater than max num or num is less than max num. So here we start with 100. Curl length is equal to 100. Maximum is equal to 100. This is unfortunate. I think we would have been able. I think we'd have had a better chance at this problem if we did it earlier in the day. Now I think I'm out of brain juice. Actual answer here is 1. I'm returning 2, so I rephrased the problem incorrectly. gain by PT. Wait, how did we get to flip game? What if we say... Yeah, I'm just trying random stuff. I think we're going to try this one tomorrow with fresh brain sauce and see how it goes.